All right, so we're going to go ahead and do an example using our proper subset definition. So in our proper subset definition, again, everything in A needs to be in B, but set A cannot be equal to set B. All right, so we're asked in this case, determine whether set A is a proper subset of set B. All right, so in set A we have jazz, which is also in B. We have pop, which is also in B. We have hip hop, which is also in set B. Right, and now we need to make sure that set B has something that A does not, and it does. Right, set B has 4 elements, set A only has 3 elements. So set B is larger, right? They are not equal to one another. But since everything in A is an element of B, we're going to say that A is a proper subset of B. We can also include that it is just a plain old subset of B. Right, so in this case, we can use both of these. Right, A is not only a subset of B, it is also a proper subset of B. So we can include both of these. Right, now if we look at example B, set A is elements A, B, C, D. Set B is elements A, C, D, B. If we look at these, the letter A is an element of both, B is an element of both, C is in both, D is in both. To fulfill our idea of proper subset, remember that set A cannot be equal to set B, and that is not the case here, right? Because these guys are equal. So we cannot use the proper subset symbol, right? But we can use the one that has the equal sign underneath. So we could say that A is a subset of B. And we can only use that one because, right, set A equals B. So if set A equals B, we can only use our regular subset notation, but we cannot use our proper subset notation. So that's the big difference between a subset and a proper subset, is a proper subset eliminates the case where our sets could be equal.